All right, so motion problems, all right? They're a little bit different than what we're doing with our other problems, but the process is still going to be pretty similar, all right? We have to start out with something a little prior to doing these problems, and there's a formula that we refer to as D equals R times T, all right? D equals RT. Do you have any idea what this stands for?
Distance equals rate times time.
Good. Distance equals rate times time, all right? So in our motion problems, it is important that we know this, all right? Distance equals rate times time. So we're gonna read our problem, and then there's actually kind of 4 different statements we're gonna be making, or 4 different variables that we're gonna be defining. That's gonna help us with these problems. At first it might seem a little weird, but once you get it down, it's pretty good. Actually, you kind of, for this whole entire page, we're just gonna define our variables once, and you don't have to repeat it for all 3 problems, which is kind of nice, all right? So, the first one, or actually first let's read it. Jack, can you read this for us? I mean, Jackson. Go ahead.
The plane flies 450 miles with the wind in 3 hours. Flying back against the wind, the plane takes 5 hours to make the trip. What was the rate of the plane in still air? What was the rate of the wind?
All right, great. Okay, so a couple things we have to do. The first thing is that we have to identify what the rate of in this case, the plane is in still air. So that's just going to be x. So x equals rate in still air. And you can actually do this on the very top. I know you probably just started on the actual problem, but you can do it on the top of the page, so it applies to all 3 of these problems. So x equals rate in still air. Y is going to be the rate of the wind. Now here's the 2 extra pieces. X plus y. You have any idea what's going to happen when we have x plus y? So the rate in still air, like the rate of your plane plus the rate of the wind.
The plane flying with the wind?
That's exactly right, right? So it's going to be your rate with the wind. So it's kind of like when you have the wind at your back. Jeffrey?
Wait, is the wind against the plane or going with?
It's going to be both in this problem. So in this situation, rate with the wind, you're flying with the wind. The wind's helping you out. All right, so it's at your back. Then we're also going to have x minus y, and this is going to be your rate against the wind. It's only abbreviated with 2 letters there. Against the wind. Neil. I can't do this. Neil.
First of all, my name is Princess.
Okay, Princess.
Second of all, wait, what would the rate of the wind? Would that be, miles against hour?
Yeah, miles per hour. So it's the speed of the wind.
Okay.
Yeah, and if we're doing a problem with a boat, we're going to be saying this is the rate of the water, or the current. All right. Okay. So now that we have all these defined and out here, we're going to go ahead and reason through our problem. So instead of setting up jars, okay, we're not going to be setting up 3 jars in these problems. We're instead going to set up a box that's going to have 6 panels, just like this. And the reason that we have it set up like this is because we're going to have R times T equals D. Okay. Now that we have all this set up, and once again, this we're not going to have to really repeat for the next 2 problems. You kind of just leave it. So now we're going to go ahead and set up our box. All right. Let's go ahead and read through this problem one more time. So everything is going to apply to this kind of little matrix here, where this first one is going to be with the wind, and this one's going to be against the wind. All right, so here we go. So a plane flies 450 miles with the wind. That's your distance with the wind. Flying, how much time did it take?
3 hours.
3 hours. Okay, and what did we say the rate was when you're traveling with the wind? How do you represent that?
Miles per hour.
It's going to be in miles per hour, but
X plus y.
Rate with the wind is x plus y. Okay. Now to do the other one. Okay. Flying back against the wind. The plane takes 5 hours to make the trip.
5 hours.
How would you fill this in, Princess?
Okay. So we would plug in 5 for t and x minus y for r.
And then
What about the distance?
the distance would be 450 because it'd still be like the same distance.
Yeah, you're absolutely right. Distance is still going to be the same. We're traveling back, right?
Oh, yeah.
So now, okay, according to R times T equals D, okay, RT equals D, we are going to have our formula set up. This row creates this formula. 3 times x plus y equals 450. And then the other one, 5 times x minus y equals 450. Just checking, is this in the frame still?
Yeah.
How far do I have? Do I have quite a bit?
Yeah, you
it's
have like
there, it's
you have like
there.
until
Good
the
to know.
calculators.
Good to know. Okay, so one method that we can use to solve this. Does anybody have any idea about how we can go ahead and solve this? Because this is now a system.
First, you could just distribute.
We could distribute. So we have 3x plus 3y equals 450 and 5x minus 5y equals 450. Do you have another idea?
You could divide 3 and 5 from both sides.
Yeah, great observation, right? We can save ourselves a lot of trouble because technically if we had 3x and 3y and 5x and 5y or negative 5y, you still have to multiply then to eliminate. Whereas here, if we divide this by 3 and divide this by 5, we end up with x plus y and x minus y. Right? Yeah, pineapple.
I'm so confused why x plus y would be rate with wind and x minus y would be rate against the wind.
Okay, so take this, let's say x is like the rate in which I'm running, right? Okay, say I'm running 5 miles per hour. And the wind is with me. Am I going to be running faster or slower? Faster. The wind is pushing me. So if we add those two together, and granted, if I'm running, wind is not necessarily pushing me faster.
Alright.
But if you're a plane or a boat, okay, it's a different story.
Okay.
So if we're a plane and we're going a certain speed, the wind behind us is pushing us. So we're adding the two speeds together and it's pushing us. Whereas if we're fighting against the wind, we're subtracting the wind away. Does that make sense?
Yeah.
Okay, so our two new equations. Can you help me set up our first equation? Or top?
X plus y equals 150 and x minus y equals 95.
Good. X plus y equals 150 and x minus y equals what?
Oh wait, 90.
90 is correct. Okay. Are these set up now for elimination?
Yeah.
Yeah. What are we going to do?
Cut out.
Good. Add them together. Clear our y. We end up with what equals what?
X equals 240.
Not x. Not x. 2x. X plus x. So 2x equals 240, so therefore x equals 120. Now, we could plug this 120 in over here, or else could we plug it in? Right here, right? So y must be what?
30.
30.
30.
Okay, we're going to bring this back over to the center, and we're going to add our labels to it. So, we have 120, we have 30. What is 120?
Rate and
Rate and still air.
Good, rate of what?
the
Plane.
Go to the plane. And you don't have to write that. We could just write 120 miles per hour in still air. So without any wind. And then what is 30?
30 miles per
The
hour.
rate of the wind. Miles per hour. You can write wind speed.
Wait, wind speed or the plane and the wind?
Take a look. What's y?
Oh,
Rate
sorry.
Rate of the wind. Okay, so if x is the rate of the plane, y is rate of the wind. Then when you go add them together or subtract them, that's referring to the speed of the plane with or against the wind. Any follow-up questions on this process? We'll do another one in a second.
It really isn't about this process, but then like these kind of problems are going to be on the word problem.
You will, yes. You will see motion problems. All right, so we'll end our video. Just a couple mishaps on our first try. Go ahead, you can hit stop.